Hello guys, this is Amar Hatti, your CAD/CAM teacher. In last video lecture we are into your fifth unit, that is advanced manufacturing method. And in last video we covered the different classification of rapid prototyping systems. Well, we have three types of rapid prototyping systems: liquid based, solid based and powder based rapid prototyping techniques. In that one we have different classifications, like we came to know what is stereolithography, laminated object manufacturing, selective laser sintering, and fused deposit modeling, and also 3D printing. We came to know what are the working principles of these rapid prototyping techniques, features, models and specification of the processes, and also we knew the applications, advantages and disadvantages of these techniques. Okay, so in today's video lecture we are going for the rapid tooling. Okay, we are going for rapid tooling after having the different classifications of the rapid prototyping technique. We are going for the rapid tooling. Well, name itself indicates it is also a rapid prototyping technique. Okay, it is also a rapid prototyping technique, but we are using here the tooling. Okay, word tooling. What is the meaning of tooling? It is a rapid process, rapid prototyping technique, and a process of manufacturing the tools using the same rapid prototyping techniques. Okay, if I am using these stereolithography, selective laser sintering, fused deposit modeling or 3D printing, by using these processes, if I am going to manufacture the tools, okay, manufacturing now not only the basic objects, if I am manufacturing the tools by using the rapid prototyping techniques, then that is called as rapid tooling process. Okay, so this tooling is one of the most expensive and slowest steps in the manufacturing process actually, because the quality of the part manufactured is heavily depends upon the quality of tooling. If you have the higher quality of the tooling, then you are going to have the higher quality or better quality of the parts what you are manufacturing by using that tool. Okay, because rapid tooling is widely used in many areas of the industries, because many different types of industries use the rapid prototyping techniques to manufacture their tools, because better the tool, better their products are. Okay, so in classification, if you go to the classification of the rapid tooling, we have two different types of rapid tooling processes. One is direct tooling and second one is indirect tooling. So what is direct tooling? So it is a process of making the same tool, die or mold directly from the CAD data using the rapid prototyping process. If I am manufacturing the tool directly from the CAD data, which I draw the object by using directly, I am using the rapid prototyping process. Okay, then that is called as direct tooling. Okay, so for example, you have seen the injection molding. The main cavity or cores, runners or ejection systems can be produced directly using the rapid prototyping processes. I am just taking the design of the data directly from the CAD model, and I am manufacturing it by using rapid prototyping process. Then that is called as direct tooling. As I said in the example, injection molding process, main cavities or cores, runner, ejection systems can be produced directly using rapid prototyping process. Okay, so what are the advantages? What are the advantages of using direct tooling? So I told you rapid tooling produces the tools with high accuracy. So direct tooling process produces tools with high accuracy also. So what is indirect tooling? What is indirect tooling? So it is a process of making or manufacturing master patterns for making tools or mold from CAD data using rapid prototyping process. Then that is called as indirect tooling. If I am directly manufacturing the tool, directly taking the CAD data and using the rapid prototyping, that is direct tooling. But if I manufacture the master patterns to make the tools from the CAD data and I am manufacturing it using the rapid prototyping technique, then that is called as indirect tooling. Indirect in the sense, I produce the master pattern. In that master pattern, I am going to manufacturing my tool using rapid prototyping process. Then that is called as indirect tooling. So subsequently, that mold is made up of silicone rubber, epoxy resins, or any low melting point alloys, or you can take the ceramic also. Then it is created using the master pattern. Okay. So you can tell the indirect process as the pre-production process, because we are making a master pattern here before manufacturing the tools. So we can call it as pre-production process. So this stereolithography process actually which gives good accuracy and surface finish and is used as indirect tooling process. Indirect tooling process. So what are the advantages? Advantages in the sense, indirect tooling, we can use it to make the master patterns. Okay, that is one of the advantage. The single master pattern can be used for making number of tools. It's not like that if I am making a single tool, then I need to go for only one master pattern. In a single master pattern, I can go for many number of tools. So indirect tooling is useful for mass production of the tools. So one of the advantages is mass production. So in secondly, based on the type of material used, rapid tooling is classified into two categories. One is hard tooling and one more is soft tooling. Basically, it is direct tooling and indirect tooling. Based on the material used, we have two different types of tooling processes. One is hard tooling and soft tooling. So what is hard tooling? So hard tooling is the process of making tool or mold from hard materials like steel. Okay, like steel, if I am using the material steel to make the master patterns by using rapid prototyping process, then that is called as hard tooling. And the second one is soft tooling. Well, the name itself indicates, this is the process of making the tool from soft materials, like you may use silicone rubber, epoxy resin, or low melting point alloys, okay, by using the rapid prototyping process. Then that is called as soft tooling. So this completes your rapid tooling process. Well, the next point is STL format. Well, I already told you before going to rapid prototyping technique, we need to convert whatever the format we designed into the stereolithography format. Okay, so what are those formats? So I said you STL format is called as standard tessellation language, or you can call it as a stereolithography file format. Okay, file format. Why we use stereolithography file format? Well, you designed your object in CATIA, Unigraphics, or any other graphical package, then that graphical package is going to save your object in its format. Well, if you do it in a CATIA, and it is going to save the model in CATIA format, like the name .cat. Okay, so that is the format. So different 3D CAD packages use different algorithms to represent the solid objects. Okay, but in order to achieve the uniformity and standardize the 3D model for rapid prototyping, these CAD file format is converted to STL file format. Because if I am taking a part from CATIA, if I am taking a part from Unigraphics, this format is different and this format is different. These things are not having the uniformity in its format. So to achieve that uniformity and standardize the 3D model for rapid prototyping technique, we are going to have a single file format, and that is the standard tessellation language or stereolithography format. So all the major CAD CAM vendors supply or CAD STL interface for conversion from CAD file format to STL file format. Okay. So what are they? What is the stereolithography file format? So this stereolithography file format represent a three-dimensional surface as an assembly of a planar triangles. Assembly of a planar triangles, like a facets of a cut jewels. Even if you have a simple surface, like simple two-dimensional surface, we are going to have, or we are going to represent that surface into a planar triangles. Well, you can see here we have a hexagon, which is cut into the planar triangles. Okay, so it feels like it is an actually a assembly of a planar triangle. Okay, so this is about your STL file format. You can see we have a conversion of the polygonal to triangular faces in STL files also. Okay, so what are the advantages of STL file format? Why we convert all the format into STL file format? In a simple sense, it is a simple method for representing a 3D CAD model, because it is going to standardize and uniform it for any applications. Okay, for any different types of rapid prototyping technique you are going for, but it is going to represent a common file format. And also it is used by most CAD systems and rapid prototyping systems. So because it is going to have a common file format. Okay, and also it can provide small and accurate files for data transfer for certain simple shapes. Okay, it can provide small and accurate files for data transfer for certain simple shapes. Okay, so these are the advantages of STL file format. What are the disadvantages? So if you see, many a times STL file is actually larger than the original CAD data file, especially for any complicated shaped objects. We are going to have the larger file sizes than its original CAD data. That is one of the disadvantage of the STL file format. And I said while doing the rapid prototyping, we are going to do the slicing of the STL files. Okay, so this slicing of STL files can take several hours. Okay, it is going to take more time to slice the STL files. So that is one of the disadvantage. And also we are going to have, or we are going to face number of flaws in STL files. Many a times it requires the repair of the software to remove the flaws also. That is one of the problem or disadvantage with the STL file format. Okay, so this is about your STL file format. So next comes is your 4D rapid prototyping technique, or you can call it as a 4D printing. Okay, as we have 3D printing, we are going to have the 4D printing also. So what is 4D printing? Well, you heard about one dimensional, two dimensional, three dimensional. Okay, what is this 4D? Okay, so this 4D is also known as 4D printing, is actually a new process and it is still in development stage. Okay, so if you are going for any research or you are going for the project presentation, if you are having or searching for new projects, you can go for the 4D rapid prototyping process or 4D printing, because this is actually a new process and it is still in development stage. So what we do actually, or what 4D prototyping, 4D rapid prototyping process actually does. So this 4D printing process transforms 1D strand into 3-dimensional shape, or 2D shape into 3-dimensional shape, or one type of 3-dimensional shape into another 3-dimensional shape. Wow, different thing, right? What we do, it is going to convert 1D strand. In a simple sense, you are going to see, you are seeing here, we have a 1D strand in the diagram. It is going to convert that 1D strand into 3D shape, or it will convert this 2-dimensional shape into 3-dimensional shape, or it is going to convert one type of 3-dimensional shape into another type of 3-dimensional shape. Well, it is a quite interesting thing. So what is the principle of operation? How the 4D printing is going to convert all these things? So in this 4D printing process, 1D strand or 2D surface having multi-material feature is created using the same 3D printing techniques available. Okay. So what we do? We are going to have the material, the multi-material feature material, and we create the 1D strand, or we simply manufacture 1D strand or 2D surfaces using the multi-material features and create this one using the same 3D printing techniques. Okay. So what is multi-material features? What is multi-material feature? So this 1D strand or 2D surface is made out of thousands of particles of different materials. Okay, thousands of different materials. The distribution of different materials in 1D strand or 2D surface is done with the help of special application software loaded on system computer of this rapid prototyping machine. So this 1D strand or 2D surface created is a single print with multi-material features, because we are using thousands of different particles of different materials. So the distribution of multi-material features, which is done with the help of special application software, right? So, and this is as per the requirement of the final 3D model to be developed. If I want to develop a 3D model, the distribution of multi-material features should be done in such a way that as per my requirement. Okay. So what we use is the multi-material use water as its activation energy. Whatever the different, as per changing the material, the activation energy or the activating agent can be changes. But in a simple sense, we can use water as its activation energy. When this 1D strand or 2D surface is immersed in water or comes in contact with water, the different water absorbing properties of the different materials in a 1D strand or 2D surface activates the self-assembly process and converts 1D strand or 2D surface into whatever the 3D shape we needed. Okay. Just we need to immerse the 1D strand or 2D surface in water, or when this model comes in contact with water, the different water absorbing properties of the different material of this material activates the self-assembly process and converts the 1D strand or 2D surface into desired shape. Okay. So you can see here in the second picture, the 1D strand, we have a 1D strand. Okay. So this 1D strand is made up of multi-material feature material. So the material distribution in this one is made in such a way that when this 1D strand comes in contact with the water, it is going to start the self-assembly process as shown in the downside picture. Okay, downward picture. So we still till now we had 1D strand, but now we have the 3D shape of the desired object. Okay, so this is how the 4D printing works. This is how the 4D printing works. Well, we have one more example also. Well, you can see here we have a two-dimensional surfaces. Okay, we have a two-dimensional surfaces, and it is also made up of the multi-material feature materials. When it comes in contact with the water, it is going to convert itself into three-dimensional model as shown in the figure. So what are the advantages of 4D rapid prototyping or 4D printing? So in a simple sense, a 3D structure can be manufactured from two-dimensional or one-dimensional surface using minimum energy. Okay, just we need to use the multi-material materials and immerse it in water. Okay. So 3D structure can be manufactured from 2D surfaces or 1D using minimum energy. And also it is a self-assembly technique for manufacturing large scale physical structures. So it is the self-assembly technique. So that is one of the advantage. So the objects that are too large to manufacture on a relatively small bed type 3D printing machines can be created using 4D rapid prototyping. Well, you can see here in 3D printing machines we have small beds. Okay, small beds. In that small beds we cannot manufacture large materials, okay, or large object. So in that case, we can use the 4D rapid prototyping process. Okay. So this is about the advantages of the 4D rapid prototyping process. Well, I said this is actually a beginning stage or in a research stage, still in the development stage. Okay. So where we use it actually. Well, it can be used in a tissue engineering and a drug delivery system in human bodies. Okay. So if I want to deliver some drugs into human systems, where if we have any organal problems, then that type of problems we can use. Well, that is tissue engineering and drug delivery system in human bodies. And also 4D rapid prototyping finds its application in spacecraft, aerospace and also automobile also. Okay. So this is about a rapid prototyping system. So this completes your first part of your 5th unit. Okay. So the second part is completely deals with your product life cycle management. Product life cycle management. So what you understood by the name product life cycle management? In a simple sense, product life cycle management. Life cycle in the sense, well, if I have a product, I need to give birth to it, and the product usages, product research, product disposal. Okay. So this is actually the life of the product. Birth, usage, disposal. Okay. So that is actually the cycle of any product. But if you are doing the management of that product from the beginning of its life to the end of its life, that is called as the product life cycle management. So what is the need of product life cycle management? Well, if you've seen in traditional philosophy of a product design is based on the principle of minimizing the design and manufacturing cost. If you go for the traditional philosophy, they had in their mind that product design is based on the principle of minimizing the design and manufacturing the cost. Manufacturing cost we need to minimize. That is the only thing, okay, in traditional philosophy. But right now in modern era we have a competitive environment. Okay, we have a competitive environment where we have a market which is flooded with large number of identical products. Same product we are going to have different companies are manufacturing it. So for the success of a product, it is not only important to minimize the design and minimize the manufacturing cost, but also it is necessary to minimize the total product life cycle cost. Total product life cycle cost. It is not only necessary to reduce the design or minimize the design and manufacturing cost, but also necessary to minimize the total product life cycle cost from the beginning, from the birth of the product to the death of the product. Okay. So what are the product life cycle cost consist of? What are the product life cycle cost consist of? It consists of the cost of the product inception, cost of the product design, manufacturing, service and disposal. Okay. So this has made it necessary to develop a plan to manage all the phases of the product life cycle from inception to disposal. At the time of inspection, at the time of design itself, we need to plan and manage the cost of all these. What is, well, you may come to know or you have a question in your mind, what is inception? Inception is actually the birth of the product, So product life cycle management is a system of managing the entire life cycle of a product from the birth to disposal. Okay, from the inception to disposal, that is from birth to death of the product, death of the product. So if I am managing all the life cycle of the product, I need to manage the inception of the product, design of product, manufacture of product, disposal of product and also the service of the product. Okay, so doing all these things, we have some phases. Okay, we have some phases. The first one is obviously the inception or conceiving the product idea. Conceiving, or in a simple sense, the birth of the idea of the product. So the first phase deals with the conceiving the idea of the product. So it starts with the in idea of the product, what we need to do. It starts with the definition of the product based on the customer requirement and market survey. Well, if you do the customer requirement and market survey, you will come to know what customer actually needs. Okay, as per that, as per market survey, you need to define the product. You need to define, I need a product in this way. Okay, so based on customer requirement and market survey, the specification of the products are proposed. The specifications of the products are proposed, and this stage is the inception of the product. So in that one, we are going to do define the product and define the specifications. Okay, so once we define the product, once we define, I need these specifications of this product, the next stage or next phase is design. Well, the second phase deals with the design of the product. What we do in design. So in design, we do detailed designing of the product and analysis of the design, testing of product through computer modeling and different prototype, and validation of the design and innovation of the product if any innovation is needed. So that is the design stage we are going to have. So once the design is over, the next phase is realize. So what is realize? So this is the phase during which the actual birth of the product takes place. Actual birth of the product takes place. That is, in a simple sense, manufacturing of the product. Once you manufacture, what we call it as, the product has taken the birth. Okay. So based on the design of these various components of the product, the process planning is carried out, and it is followed by manufacturing of the component and assembly of the product. So we are going to have the right now model. The right now we have, once we manufacture and assemble it, we have the real time product in our hands. So the product is then handed over to sales department, which sells and delivers the product to the customer. Okay, so this is we do in the phase 3. Well, the fourth stage or phase is the service. Fourth phase is service. What is service? So this is a phase where real interaction of the customer with the product starts. Real interaction of the customer with product start. So this process involves different product training of customer, use of the product by the customer, or if any repair or maintenance support by service department or the organization is needed, we are going to provide that with the customer. Okay, if it is going to involve the product training to the customer, use of the product by the customer. If repair or maintenance support is needed, then we are going to provide it to the customer. Okay, so this is the phase we do in realization, service. Okay, service. So the final thing or the final phase is disposal. So this is a last phase of the product life cycle. It involves the advice to the customer about the retirement of the product and its replacement, the disposal and recycling of the product without causing any damage to the environment. Okay, so what we do in the disposal, we are going to advise the customer about the retirement of the product. Well, if the product what we manufacture has a retirement also, right? Well, it is going to work well and good till this much of years. Okay, so after that we need to advise him to replace, dispose and recycle the product without causing any damage to the environment. So these are the phases of the product life cycle management. So what are the different benefits using product life cycle management? Well, I said as per traditional philosophy, we are not only reducing the cost of design and cost of manufacturing, but we are reducing the cost of whole life cycle of the product. So we are going to have the lower product life cycle cost. Okay, so if we are taking the better care to improve the product, then we are going to have the improved product quality if we are using product life cycle management. And also this PLM system avoids the time consuming activities or replication of the same data in different parts of the systems. We reduce that one, and we avoid errors and reworks in the process. So result of all these will give you the increased productivity by using the product life cycle management. So you are using the different techniques, then you are going to have the different innovations in the product. So this product life cycle management will give you it is going to bring the product innovation, okay, and the faster time to market. Well, if you are manufacturing anything with lesser cost, with high productivity, with lesser time, then the marketing value has its, and marketing has its higher time, so faster time to market. And also, of course, increased earning of the company. If we are having the low product life cycle cost, improved product quality, increased productivity, innovations in the product, then definitely there is an increased earnings of the company. So this is about your product life cycle management, the first part in your second part of your fifth unit. Okay. So the next topic in your fifth unit is collaborative engineering. Collaborative engineering. What is collaborative engineering? Well, the name itself indicates collaboration. Okay, collaboration. If I define it in a technical terms, the collaborative engineering is defined as a discipline for the study of interactive process, different processes of the engineering collaboration, where multiple interested stakeholders or partners are going to resolve their conflicts, bargain for individual or group advantages, agree upon course of action, attempt to achieve joint outcomes. All these things are done for serving their mutual interests. Okay, so this is the definition. If I'll tell you once again, it is defined as a discipline for the study of different interactive processes of the engineering collaboration, where multiple interested partners are going to resolve their conflicts, bargain for individual or group advantages, agree upon course of action, and attempts to achieve joint outcomes, and all the result of these things for serving their mutual interests. Okay. So what is the aim of collaborative engineering? The aim of collaborative engineering is to facilitate the individuals and the organizations across the boundaries of the discipline, geography, and culture to work effectively with collaborative actions for achieving their joint outcomes. Aim of this one, in simple sense, to get the individual and organizational benefits. Even if you are having different boundaries of the discipline, even if you are having or living in different geography of the areas, different cultures, but work effectively with collaborative actions for achieving the joint outcomes, joint goals. Okay. So where the application of the collaborative engineering, where we are going to apply the collaborative engineering. So it is most effectively used in product design and manufacturing and construction. Actually, design, manufacturing, and construction, we use collaborative engineering. Okay. So till now we completed your fifth unit. Let's go for just a simple ride. So beginning, we came to know that what are your syllabus of the fifth unit. In the first thing, we came to know what exactly the categories of the manufacturing process. We have three types of the categories: subtractive, additive, and formative manufacturing process. Okay. After that, we came to know that the introduction of the rapid prototyping. What are the basic steps in the rapid prototyping technique? We have pre-processing, processing and post-processing. Well, in that one, first one is 3D CAD modeling, then pre-processing. In that one, we have all these things. Then the post-processing. After that, we came to know that what are the different benefits of rapid prototyping, limitations of the rapid prototyping, and the different classifications of the rapid prototyping techniques. Well, in classification, we are having three different classifications of the rapid prototyping. The first one is liquid based rapid prototyping, second one is solid based rapid prototyping, and the third one is powder based rapid prototyping. Well, if you see in the first one, the liquid based rapid prototyping, we have two different types of the rapid prototyping process. One is stereolithography, then the next one is polyjet modeling. But as per your syllabus, you have only stereolithography process. So we came to know what exactly the stereolithography process is. Well, in the second one, we have the first one, the fused deposit modeling, then the laminated object modeling. Okay. Well, in the third one, we have selective laser sintering and 3D printing. These are the different classifications and different rapid prototyping processes. So in today's class, we had rapid tooling. In that one, we have two types. One is direct tooling and indirect tooling. As per the different materials, we have two types of rapid prototyping process. First one is hard tooling and second one is soft tooling. Okay. After that, we came to know that what are the different STL file formats, not different STL file formats. What exactly the meaning of STL format? Okay, that is standard tessellation language or stereolithography file format. To achieve this uniformity and standardize the 3D CAD model, we use STL file format. Then the final part of your first part of your fifth unit is 4D rapid prototyping process. So 4D rapid prototyping we had today itself. Then we had product lifecycle management, your second part of your fifth unit. We came to know what are the different phases of the product lifecycle management. Then finally the collaborative engineering. So this completes your fifth unit. Okay, simple. We don't have any numerical part in your fifth unit. We have only theoretical part in your fifth unit. So in the next video lecture, we are going to start your sixth unit, that is automation and robotics. Okay.